Isosceles triangle, which the triangle has two sides that are of equal length, so they're marked equal length. The legs are the equal sides of an isosceles triangle, so these are the legs. Okay. And then we have the base, which is the third side of the isosceles triangle, so whatever's not the leg is the base. Then you have base angles. Those are angles opposite the equal sides. So basically, if you were to, if you were to take an arrow and draw like this, how these are opposite and these are opposite, that's where you get the base angles. And then you have the vertex, which is opposite the base. So the part in between the two legs is the vertex. Theorems. One of the theorems says if two sides of a triangle are congruent and then the angle opposite those sides are congruent. So basically what this theorem tells us is we have an isosceles triangle, and then if these two legs are congruent, that means these angles are congruent. And then we have another theorem that's basically the opposite, that says if these two angles are congruent, that means these two legs are congruent. Equiangular. Equiangular means all the angles are equal. Equiangular triangles are also equilateral. So if you have all the angles equal, that means all the sides are equal. And then vice versa, if all the sides are equal, then all the angles are equal. And that happens because when you have a equiangular triangle, well, they're kind of all base angles at that point because these two are congruent, these two are congruent, these two are congruent, and then the sides opposite those are also congruent, and vice versa. If I have sides that are all congruent, then the angles opposite those are also going to be congruent. Does that make sense? Every angle in an equiangular triangle measures 60 degrees. If you think about it, a triangle is 180 degrees, and it has three angles. So 180 divided by 3, 60. And then if we have an isosceles triangle, so we know it's isosceles, and we come in with an angle bisector. Oh, darn it. I'm off. Oh no, I can't go in the middle. Well, okay, we're going to pretend I'm in the middle. And so I've bisected this angle. So that's the angle bisector. Whenever that happens, we're going to get a perpendicular intersection, and it's going to make these two parts equal length. If I know that these two legs are congruent, that tells me that these two angles are congruent. So if this is x, this is also x. And a triangle is 180. So if I take 180 and I subtract that 50, that's going to give me 130. There's two x's here. Well, 2x is going to equal 130. Divide that by 2, and x is 65 degrees. So let's look at this one. You guys can all tell me this first one. Okay. And what that's telling me is that this side is the same length as this side. So that tells me that this triangle is isosceles because the definition of isosceles is to have two congruent sides. Okay, and so since it's an isosceles triangle, that makes the base angles congruent as well. So base angles in isosceles. I never do spell isosceles right. I always leave out that S. Are congruent. Okay, so now I know these are the same. And I'm trying to say that 1 and 3 are the same. That's what I'm trying to prove. So if I know 1 and 2 are the same, 2 and 3. 2 and 3 are the same because they're vertical angles. And if 1 is the same as 2 and 2 is the same as 3, that makes 1 the same as 3. You could either write substitution. Substitution is with an I. Or you could say transitive. Either of those words would work. Substitution is probably the easier one to remember. A quadrilateral is any four-sided figure. So it can be a square or a rectangle or a trapezoid or a rhombus or a kite or a parallelogram. That's not a parallelogram. Or something that doesn't have a name, that just has four sides. Actually, this does have a name. It's called Star Trek emblem. Anyway, any four-sided figure.
What's that called?
Oh, it's the Star Trek emblem. If you rotated it, it's up. It's like sideways. But do you remember the Star Trek emblem? No. The thing they have on their shirt. It goes like that. And anyway, doesn't matter. I'm just being a nerd. Don't mind me. So quadrilateral, any four-sided figure. Parallelograms are a little bit more specific. Whenever we draw a parallelogram, and you're just saying like, oh, draw a parallelogram, we tend to make everything slanted. That's the typical thing you think of when you say parallelogram. But squares, really, this thing hates me. Squares and rectangles are also parallelograms. Anything where the opposite sides are parallel is a parallelogram. So if we come back to the shapes that I drew initially, these are parallelograms. Trapezoids, rhombuses, kites, other quadrilaterals are not. Okay. We have theorems that say the opposite sides of a parallelogram are congruent. So if you go to your next page, there's a parallelogram here. And we have opposite sides congruent. So these two sides are going to be congruent. And these two sides are going to be congruent. So if I mark that AB will be congruent. Okay, why is this? Hold on one second. So AB is congruent to CD. And then BC will be congruent to AD. So that's the opposite sides that are congruent. That's one theorem. Our next theorem is that opposite angles of the parallelogram are congruent. So I'm going to mark those in purple. So this angle, I'm going to call it angle B. And this angle are congruent. So angle B is congruent to angle D. And then angle A is congruent to angle C. So that's the second theorem. I'm going to go back again for just a second. Then we have the diagonals of a parallelogram bisect each other. So here's a diagonal goes across from vertex to vertex. And these bisect one another. So I'm going to have to put 3 because I know you guys aren't maybe using colors. So BE is congruent to ED. And AE is congruent to EC. And then the last little note on here, consecutive angles of a parallelogram are supplementary. So, oh, this should have, I'm sorry, I marked that wrong. I should have 2 lines, not just 1, because these 2 are congruent and these 2 are congruent, but they're not congruent to each other. So if we talk about the angles again, consecutive angles, it's if you're going around the outside. Consecutive is A and B, and then B and C, C and D, D and A. So all of the consecutive angles are going to add up to 180. Okay. And then we have another interesting thing that's not a theorem, but I mean it is, but not from here. Parallelograms are made up of parallel lines, correct? And they're cut by diagonals, which is the same thing as a transversal. So what you have is, say, between this parallel line and this parallel line with this transversal, you have alternate interior angles here and here. So what I'm going to do is I'm just going to label these with color. This angle and this angle will be the same, these 2. And then this angle, can you see the yellow? This angle and this angle will be the same. And you get the same occurring with the other 2. This angle is the same as this angle. And pink. This angle is the same as that angle. So these kind of catty corner angles will be the same. Well, we have x's, y's, and z's, and what we know is that this line and this segment are congruent, and this side and this side are congruent, and these 2 angles are consecutive. So if we start with our angles, consecutive angles add up to 180. So we're going to add those 2 angles together. If they had been on opposite corners, we would have set them equal to each other. But they're on the same side, so they equal 180. So I get 10x minus 30. Oh, sorry, I wrote 17. It's not 17, it's 7. Sorry about that. So minus 20 is equal to 180. Add 20 to both sides. 10x equals 200. Divide by 10. And x equals 20. All right, so then we're going to do the y's. Now, my y's are on opposite sides, so that makes them congruent. So if they're congruent, they're equal. So I'm going to set the y sides equal to each other. Okay, I'm going to subtract 3y from both sides. And I get 2y minus 6 equals 4. add 6 to both sides, and you get 2y equals 10, so y equals 5. Oh, that doesn't work.
So this consecutive is equal to 180?
Mm-hmm. And the opposite sides are equal to each other. Congruent is equal to each other, yes. That didn't work. All right, so next we have the z's, and that's on the shorter sides, and those two sides are also equal. So 5z is equal to 3z plus 8, and you're going to subtract 3z from both sides. So I get 2z is equal to 8, so z is equal to 4. All right, so MNOP is a parallelogram. What's that? Okay, and then MNP, that's this angle here, is congruent to OPN, that's that angle here. Because these lines are parallel, these are alternate interior angles. Okay. ONP, that's this angle here, is congruent to MPN, which is this angle here. Those are also alternate interior angles. And now I have two triangles that are congruent from angle, side, angle. Oh, I forgot reflexive. Thank you. I skipped a line and went to the next line. So I have reflexive property, and then I have angle, side, angle. So now I have two triangles that are congruent, and then I'm asking about two parts to be congruent. And if I have two triangles that are congruent and I want to know the parts, it's CP, CT, C. So congruent parts of corresponding parts of congruent triangles are congruent. What? You want to write it out the long way? Okay, corresponding parts of congruent triangles are congruent. See? Long way. All right, so we have some parallelogram theorems. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. It's hard to say that word sometimes. So basically what you have, if you have some quadrilateral, and you're able to say that both sides of opposite pairs are congruent, if this situation occurs, then you have a parallelogram. Likewise, if one pair of opposite sides are parallel and congruent, so if I call this AB, CD, so if AB is parallel to CD and AB is congruent to CD, then you have a parallelogram. So these are things that you have to prove in order to prove parallelograms. We have one that says if both pairs of opposite angles of the quadrilateral are congruent, so if this angle is congruent to that angle and this angle is congruent to that angle, then you have a parallelogram. So opposite angles congruent. And then you have if consecutive angles are supplementary. So actually let's do if so you have consecutive angles, so consecutive is going in order around. If those are supplementary, so they add up to 180, then you have a parallelogram. Bisect each other. So if the diagonals of a quadrilateral bisect each other, so if you draw diagonals and you get a situation where this length is equal to that length and this length is equal to this length, then you have a parallelogram. Record that. So if you can do any one of these 6 things, then you've proven it's a parallelogram. So you can either prove that the opposite sides are parallel, both pair. You can prove that both pair of opposite angles or opposite sides are congruent. You can prove that one pair of opposite sides is both parallel and congruent. Both pairs of opposite angles are congruent. Consecutive angles add up to 180, or that the diagonals bisect each other. If you can prove any of those things, if you can show any of those 6, then you can say, okay, this is a parallelogram. So hopefully that will help. All right, so, oh, I need to pause here. That's really what's happening here. We're cheating. We're going to, instead of doing this algebraically, which is time consuming, we're going to do this graphically. So anywhere on your graph paper, you draw an axis. These are all positive, so I only need this section. And I'm going to plot all my points. And so that it's easier to see, let me make sure I can do that. 2, okay, now I guess I'm going to have to go by. Okay, so I'm going to plot B. So it's 2, 1, 2, 3, 4. That's B. And then A was 0, 0. So that's there. Actually, let me move it up. I'm just moving mine up. You'll be fine. Just want it to be easier for you guys to see. So 0, 0 is here. 2, 1, 2, 3, 4 is there. Then I have 6, 0. And I have 8, 4. So 6, 7, 8. 1, 2, 3, 4. Okay, so here's A, B, C, D. Now you can draw the parallelogram if you want to, but you don't have to. What we're going to do is I'm going to prove that opposite sides are both congruent and have the same slope. Or so that would make them parallel. If opposite sides are congruent and have the same slope, then you have a parallelogram. Okay? Basically, if I look at this as a triangle, right? It's a right triangle. So if these 2 legs are the same, like I can figure out what the distance basically was here by knowing the legs. And if those legs are the same as these legs, then these 2 distances would be the same, right? Also, we'd have rise over run, which tells me slope. So all I have to do to prove if these 2 parallelograms are if this is a parallelogram, is to prove that this length and this length is the same as this length and this length. Then I have the side lengths the same and the slope the same. So I count 1, 2, 3, 4. So I go up 4 and then over 1, 2, over 2. 1, 2, 3, 4. I went up 4, over 2. These are the same? Yes, it's a parallelogram. You could draw that, yes. Because if I can prove that opposite sides are the same length and they have the same slope, so they're parallel, then it's a parallelogram. Well, I don't actually have to know what the length is. I just have to know it's the same. Well, if I have right triangles with the same lengths of legs, then the hypotenuse, which would be this line here, is going to be the same. I don't need to know what it is. I just need to know it's the same. And if I go up the same over the same, then they have the same slope and they're parallel. So all you have to do is count the distance between the two sets of points. If they match, you have a parallelogram. If they don't match, you don't. And that saves all of this algebra that you don't have to now calculate. Just, again, I'm going to plot these points. So that's A, 0, 0. B is 3, 4. So 1, 2, 3, 4. C is 10, 4. So that's 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. And D is 7, 0. So that was 10, 9, 8, 7. Okay, so I've plotted the points. This one's C. And I'm going to count those spaces. So I'm going to go up 1, 2, 3, 4. So I'm going up 4. And then over 1, 2, 3. And then I'm going to check between C and D. I go 1, 2, 3, 4. 1, 2, 3. Matches. So this is a parallelogram. Why don't you guys try D and tell me what you think? No, that was not a parallelogram. Any questions on this at all? Okay.
We're gonna have a lot more than that.
There's some on the homework. All right, so now we're going to use the values that we have of a parallelogram to solve this. What do we know about opposite angles? So yeah, so x is going to be 110 and y is going to be 70. We know opposite sides are the same, so y will be 31. And now this one is a little bit more complicated for x. Remember I showed you on that diagram that these two angles are the same? Mm-hmm. And then these two angles are going to be the same. So I know 26, but I don't know x. But this makes a triangle, which would be a total of 180. Do you see that? So if I do 117 plus 26, I'm going to get 143. And then I'll do 180 minus 143, and that gives me 37. So that's what x equals. Does that make sense? All right, so we're going to look at those. I mean, this is already here, but we're going to explain it and go over why this works. And remember, we had that list of 6 things you can do to prove that things are a parallelogram. Well, it's giving us a lot of information. So we have that N is a midpoint of MO. That makes these two the same length. And then we have that Q is a midpoint of RP. That makes these the same length as each other. And you'll notice I'm not using different markers because MOPR, that's this large shape outside, is a parallelogram, which means that this length is the same as this length, right? So that's property of parallelogram. That opposite sides are congruent, or sorry, that they're parallel, and they're also the same side. So that's also a property of a parallelogram. It's the definition of a parallelogram that the opposite sides are parallel and congruent. Now, MN and NO being the same length and RQ and QP being the same length is because of this midpoint situation. So that's definition of midpoint. Okay, and now if we have M and PQ, that is this smaller parallelogram inside the larger one. We wanted to say it's a parallelogram. Well, we know that these lengths are parallel and congruent. So we have opposite sides are parallel and congruent. So that's definition of parallelogram. Interesting little thing. A square is both a rectangle and a rhombus. So every square is a rectangle, every square is a rhombus, but not every rectangle is a square. And not every rhombus is a square. If you had a Venn diagram, you guys are familiar with the Venn diagrams, right? The circles that overlap. Oops, I'm pushing the wrong button. Circles. If I have like that, if we call, let's say we call rectangles our E's and we call rhombuses our H's and squares are just S's. These are our E's, these are our H's, and the S's is where they meet. So squares are both. All right, so the diagonals of a rectangle are congruent. So we go to the next page. We have every rectangle is a parallelogram with 4 right angles and congruent diagonals. So if we put diagonals in there, that's a terrible diagonal. And I call this ABCD. AC is congruent to BD. The diagonals of a rhombus are perpendicular and each diagonal bisects 2 angles. So if I go back to my rhombus and I put in my diagonals of my rhombus, what I get is perpendicular angle, and then these are bisected, so those are all equal, and then these are bisected, so these are all equal. And if I called this one EFGH, angle E is congruent to angle G, and angle F is congruent to angle H. And all 4 sides are the same length. And then you have squares. Okay, sorry, we have parallelograms with right angles or rectangles, and parallelograms with 2 congruent adjacent sides. So adjacent goes next to each other. So if these 2 are congruent, it's a parallelogram, it's a rhombus. And then you have squares, and squares are both rectangles and rhombuses. So in a rectangle, you have congruent diagonals. And in a rhombus, you have diagonals that bisect and are perpendicular bisectors, angle bisectors. So in a square, oops, wrong tool. In a square, your diagonals are going to cut all of your angles into equal halves. So you'll get 8 equal angles, and they'll be perpendicular. And if we call this MNOP, MN is congruent to, sorry, MP, MO. Diagonals, I'm talking about. MO is congruent to NP. So your diagonals are congruent. So squares have the properties of both of these. We like to do the cheats, right? So we're going to draw and count.
So there's negatives on this one this time?
Are there?
Yeah. -3. I mean 2, 3.
Oh, yeah, okay. So make this a little bit bigger. Not bigger, not move. Grow. Okay. So I'm going to insert some axes. And I've got some negative x's, so I'm going to make my axes over a little ways. And then I'm going to come in, I'm going to plot the points that I have, A, B, and C. I don't know D. So A is -2, 3, 1, 2, 3. B is 1, 7, so 1, 2, 3, 4, 5, 6, 7. C is 6, 7, so 1, 2, 3, 4, 5, 6, 7. C. But you'll notice I'm not putting D on this picture yet because I don't know the coordinates of D, so I'm going to find the coordinates of D. And there are 2 ways I can do this. Do you see how this is supposed to be? It's a rhombus, right? Which means that these 2 lines, opposite sides, will be the same length. And nicely, they're flat. So in this example, all I have to do is count over the same number of spaces. So if I go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here's where D needs to be. We find the coordinates at this point. 1, 2, 3, 1, 2, 3. Done. So this was 5 spaces.
So then you make that one 5 spaces?
And this one was 5 spaces. And I could do that because these were flat. Okay? If they had not been flat, hypothetically, like these had not been flat, I would do the same as I did with parallelograms. I would count how many spaces down and over, or up and over, whichever. Well, I would go down and over because I need to find this over here. So I'd go down however many, over however many, and then I would go the same distance this way, and I would find this point. So if these aren't flat, like if this rhombus was turned, does that make sense? Like it wasn't, it was drawn more like this, so you're not flat. Then you're going to count the points, number of spaces here to here, and then go the same distance, and you'll find your other point. So the same as we did with the parallelogram, only backwards. Instead of going from a point to a point, we're going from a point to finding a point. Yes, we're going to go down and back instead of up and over. Does that make sense? Let me find one that's not flat. Let me draw one that's not flat. I'll show you what I mean. I want okay, so I'm trying to find the other corner, and obviously this is not flat, so I can't just go straight across. So I'm going to count from here to here. So I go 1, 2, 3, 4. 1, 2, 3, 4. So then I'll do the same thing here. I'll go 1, 2, 3, 4. 1, 2, 3, 4. Wait, right? 1, 2, 3, 4. 1, 2, 3, 4. and here's my point that I need, and this will make my rhombus. So if EDC is 37, so that's EDC, that's here, 37. What's EDA? Okay, it's a rectangle, so what's this whole angle? 90. Yeah, so this is going to be a 90-degree angle. And if part of it's 37, we do 90 minus 37. So that's, 53. LKJ is 29. HIL is how much? Well, it's a rhombus, which makes it a parallelogram, which makes these two angles the same. So 29. QO is 17. So what is MO? Remember, the diagonals bisect each other. 34. Yeah. So it's going to be, because this is half, so this would also be 17. So you're going to have 2 times 17. Does that make sense? Right. And then here we have a rectangle. So I'm going to get some graph paper. Do you want to see it the algebraic way? So I have negative 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 5, 1, 2, 3, 4, 5. That's A. B is negative 9, 1. And C is negative 4, 1, 2, 3, 4, 1. And this is a rectangle, right? So this side is going to be flat and this side is going to be flat. They're parallel. So if this is 1, 2, 3, 4, 5, I go 1, 2, 3, 4, 5. Here's my missing coordinate. And then I find it 1, 2, 3, 4. So it's 4. 1, 2, 3, 4, 5. Negative 5. So D is 4, negative 5. That's what I meant. I mean, I was just trying to see if you guys were paying attention. Yes, it would be negative 4.